How is the heat of reaction measured, and what factors influence the magnitude of this heat change during a reaction? What is the heat of transformation? And how does it differ from the heat of reaction in terms of phase changes or structural transformations in a material? How does the heat of transformation relate to phenomena such as melting, boiling, or solidification, and why is it important in the study of phase transitions? What role do phase diagrams play in understanding the behavior of materials under different temperature and pressure conditions, and how can phase diagrams be used to predict phase changes or material stability? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How do phase diagrams help in identifying the regions where specific phases exist, and what information can they provide about the equilibrium states of a substance? What is the concept of reaction rate, and how does it describe the speed at which a chemical reaction occurs? What factors influence the reaction rate, and why is it important to measure this rate for understanding the efficiency and control of reactions in various industrial and scientific processes? How does crystallization rate impact the formation of crystalline structures in materials, and what are the key factors that determine how quickly crystals form? Why is the crystallization rate important when analyzing the properties of materials, such as polymers or metals, and how does it affect the final properties of the material? What is crystallinity in polymers, and how does it describe the degree of structural order in polymer chains? How does the level of crystallinity influence the physical properties of polymers, such as strength, transparency, and thermal resistance? How can the crystallinity of polymers be determined, and what methods are commonly used to measure this property? What is sample purity, and why is it critical to consider when conducting thermal or chemical analyses on materials? How does sample purity affect the accuracy of measurements such as specific heat, reaction heat, and crystallinity, and what steps can be taken to ensure high purity in samples used for analysis? How does the presence of impurities influence the thermal behavior of a material, and why is understanding purity essential for obtaining reliable experimental data? What is the specific surface area of a material, and how is it defined in terms of total area per unit mass? Why is the specific surface area an important property to measure in material science, and how does it affect the behavior of materials in different applications? What are the main methods used to test specific surface area? And how do techniques like adsorption, gas permeation, and others contribute to determining this property? Why is adsorption considered the most commonly used method for specific surface area testing? And what makes it particularly accurate for these measurements?